All right. Good evening, YouTube. Welcome along to Introduction to Knowledge Graphs with Grakn and Graql. We're joined by Daniel and Thomas this evening from Grakn, so I won't spoil. No spoilers. I'll just go straight on. Just a quick intro from us. A happy new year to everyone, of course. First event of 2020. Thanks again to everyone that helped, shared, and listened in 2020. We wrote a quick little article. It's at nor.dev/2020. But yeah, thanks to everyone. Upcoming events, how I cheated at my son's homework, which should be an interesting event. We're joined by Marcus from UBO, who's got a pretty awesome automation platform that allows him at least to cheat on his son's homework. I don't believe he's given the software to his son yet. Building a real-time serverless app in Blazor using AWS. Finally got some Blazor action on the roster, so that's next month, February. Also, let's go build a bot every Wednesday. Our Wednesday streams, you'll be joined by Dom this month, building a bot in Golang. Try not to get the song in your head because I've kept getting it in my head for the last, I don't know how long. Virtual social club, of course, as well. But physically distant, not socially distant. We're still going Fridays, 5:30 till late. Join us whenever, drop by. The Zoom link is floating around all over the place now, to be fair. It's a wonder we don't get bombed. That's not an invite. Quick shout out to the user story, of course, as well, sponsoring the very Discord server I was mentioning a moment ago. There's a QR code on the screen, nor.dev/Discord. Otherwise, a big thank you to them. They support the quarterly engagement prize there. So that's fantastic. Thank you. If you need UX and design, research, their lab, etc., pop along, userstory.com. We're still looking for corporate sponsors. So if you'd like your name to appear here, oh, it's not here. If you'd like your name to appear here, your organization, get in touch. A massive thank you to our patrons, as usual. We've got a new patron, John. So thanks for joining the ranks. They have quite literally kept the lights on this year, bring us out of the red every month, which is fantastic. But anyway, as I say, I'm going to get out of the way because none of you have come here to listen to me. So let's connect to the nodes, or as I've actually been corrected, there's no such thing, but we'll find out more. I'll stop my share and pass over to Daniel. I also need to make you co-host, Thomas. Bear with.
Thank you so much, Alan.
Over to you. Welcome, Daniel.
It's so great to be here. And Alex and I got connected. I want to say October, sometime late last year, and I was super impressed and just really loved the community that you all have built down in Norfolk. And so I'm so excited, and we're honored to be the first Norfolk Dev event, NorDev event of 2021. So we're just super glad to be here. And we're both based in London. Grakn Labs, we're based in London, so we're not too far away. Yeah. So do you want to share the presentation real quick? Is it the new sites? No, it doesn't. That's okay. So first thing, before Tomas dives in, we also have a Discord community. It's I can just drop it here in the chat for anybody that is interested. It is obviously focused on Grakn, our database, but we have a ton of community members from all over the world that explore applications for graph technologies. You can see Alex is in there, or rather Tomas is showing it now. And we have a really great time. There's a ton of really interesting projects happening. I encourage you to browse around, say hello. I'm at Daniel and at Tomas, and then I think I'm at Daniel as well in the NorDev Discord. So you can always reach out to me there. The other thing I want to mention is our YouTube channel. I like to call it our sort of inspiration hub. The first step is always to translate how this technology is going to fit into my domain, into my projects, into the problems I'm trying to solve. And all of our community presentations, so all the community members that present on their projects using Grakn, they're all on YouTube here in the on-demand playlist. We had a global conference, a user conference back in February, right before lockdown. You can find all the sessions in there. It really is meant to give you some inspiration and insights into what Grakn is being used for currently. So definitely check that out, and hopefully we see you around Discord. From here, passing to Tomas.
Yes, good. And the link that that Daniel shared to you will take you here, where you can launch and go immediately into Discord, what I just shared. But first, thank you all for having us today and letting us share our work at Grakn. I think a few years back, I may be mistaken, but I think your community also organized a meetup event on Grakn, but I may be mistaken there. But there was or in the area a few years back, our first meetup that we didn't organize was organized somewhere around your area, I believe. But it's been 3 or 4 years, so my memory may not be perfect. So first and foremost, how much time do you have?
You have till 9:50 with Q&A at the end, yep. So normal time. Okay,
great, good. So thank you all for joining the session, and we do a lot of these. Daniel and I, we do a lot of these webinars. I think we've done 60 or so in 2020, and it's been fun. So this is for us always exciting to share with, especially with a new audience. So I'm excited to hear the questions that you have and get to know your backgrounds, and especially how you're looking to use Grakn. I would encourage any questions you have to either post them in the Q&A. Daniel is an expert at answering and monitoring questions while I speak. Usually that's so that by the end of the talk, there's no questions left, because Daniel did such a great job answering all of them. But first, I want to talk a little bit about why did we start Grakn? Why did we start a new technology to do what we do? And we start with this quote. Civilization advances by extending the number of important operations we can perform without thinking about them. This quote was from Alfred North Whitehead, who said this about 100 years ago. And there's something very powerful in this quote, which touches on the idea of creating abstraction layers within technology. And to us, we look at abstraction layers specifically in programming languages. And we'll get to that later in the presentation. We'll come back to this. But this really drives our engineering spirit. But what do we do? What's our background, and what's the inspiration to building Grakn? Now, our background from a computer science point of view sits in symbolic artificial intelligence, specifically in knowledge representation and automated reasoning. Now, many people, especially in the wider industry, are not really familiar what that means. It sits under a type of AI research, but to elaborate on what both of these fields do, let's look at them both. So first, we look at knowledge representation, and we define it as a system to encode domain knowledge consistently for logical interpretation, potentially by a computer. So, for example, if we're trying to represent a model, for example, we say that there's a mammal that has a subtype as a human being, and then there may be instances of those humans. In this case, Alice. We may also say that there are other types of cats, of mammals, in this case cats, where there may be different types of instances, in this case Bob. And then modeling that allows us then to infer facts, such as, given that Alice is a human, we can now infer that Alice is also a mammal. And that leads us to automated reasoning, which we define as being a system to derive logical conclusions from 2 or more propositions that are believed to be true. So if we have 2 propositions the first saying that if a man is mortal, and if Socrates is a man, we can now infer that that Socrates is also immortal, without having to explicitly know that third fact, that Socrates is immortal up front. Now, but this begs the question, where can we apply these types of technologies? And one such domain is, let's say we have a very complex network. Let's say a supply chain where we've got a product that needs to reach a destination. So we model a product, we model that destination. But along the way, there's all these constraints. There's delivery methods, there's employees, there's availability, and there's all sorts of things that we have to model. Now, if we're trying to do this in SQL, very quickly, the model becomes too complex. And we end up with SQL queries that look like this, which by the look at some of the on the video, it's not too unfamiliar. But what is it that makes data complex? And there's a couple of things that we highlight here. Now, the first is type hierarchies. So complex data has a lot of different type hierarchies. And we can find type hierarchies in entity types, in relation types. And if we think of entity types, we think of a hierarchy that says, given an animal, we can create two subtypes, mammals and reptiles. And then we have two subtypes of mammals, we see humans and cats. And here, that every single human necessarily is both a mammal and an animal, but not all animals will be humans. And we can do the same for relation types. And we have all sorts of different types of relations that we also want to model. Unary and binary relations. And these can be divided into reflexive relations, symmetric relations, transitive relations. But we also need to model ternary, n-ary, and infinitary relations. We want to be able to model nested relations and equivalent relations and much more. The point being that if we're then looking at how do we query such networks of data, we're looking at a network like this. Let's say we've got a bunch of different types of organizations, companies, charities, in different premises, needing to get to different destinations or located in different locations. If we ask a question that says, which organizations have premises in the UK? The question inherently asks, what companies, charities, or universities? And by it asks premises, it asks for all the different subtypes of premises. And the same thing with the UK. It asks for every single type of location in the UK, whether it's a city, whether it's a ward, whether it's a town, whether it's a county. So how do we make sure that that question gets answered? Now, if we have a model that would look like this, we could end up with a query that becomes very permutative and verbose, because effectively this is akin to having to write a query path in which the number of permutations of the actual query becomes 3 to the power of 3, having to write all the different permutations that can exist in this particular example. But why are we able to handle complexity with different or existing solutions? Now, the first is that when we look at SQL, we're working with a too low-level data model. Specifically, we work at third normal form, and we're killed by joins if we're doing complex queries. If we look at graph databases and NoSQL databases, we're working with no schema, there's no constraints, and we're also working with a very low-level data model. And then finally, if we look at our RDF and OWL, we're also looking at a very low-level data model. It's verbose, built for the web, using open world assumptions, and designed for logicians. The sum of all of this is that we say current database languages are really too low level to handle complexity. So now, that's why we built Grakn. Grakn being the knowledge representation system, and Graql being the language. And if there's any geeks on the call, if you want to define Graql as a language, Grakn is really a language a fifth generation language. And that means a language to declare logic and constraints to the computer rather than to instruct algorithms. And this is the knowledge model that encapsulates the entire model. And for perhaps those familiar, this is actually a direct implementation of the enhanced entity relationship model. And so that is a direct implementation of the data model in Grakn. And that's really important, because when you're trying to, if you think of SQL having to normalize your data from some sort of ER diagram to a table, it is a very difficult, can be a very difficult process. Some may go straight into modeling things into tables, but instead, why don't we model at a higher level abstraction, at a more conceptual level? And so that's why we say that a knowledge schema needs to be able to represent type hierarchies, hyperrelations, and finally rules. So the model itself consists of entities, attributes, and relations, all which are first-class citizens in the model. And then we have rules that determine, like, create logic in order to perform automated reasoning. And finally, there's the notion of a role that determines the context in which something plays a role in the context of a relation. And as you can see here, it should hopefully starting to make sense that in the Grakn model, anything can relate to a relation. So we can have relations and relations. We can have relations between attributes. We can have relations, well, of course, between entities, but also between entities and relations. At this point, I'll do a quick demo, actually, what this means in practice. So I am now switching my screen, and you should be able to see what we call Workbase. So Workbase is effectively an IDE to work with Grakn. It's a desktop application, and there's a demo data set that we got that is loaded right now. It's a financial data set, and if you look at the top, you see the query that we asked, and below I already ran the results. But basically, it says the results. The query says, give me a bank. So we're saying $B, the $sign denoting a variable name. $B is a bank. We're saying there's a risk score which we attach to this variable name $R. The risk score has risk level high. And then we say the bank plays the role of risk subject, and the risk score plays the role of risk value in a risk exposure relation. So the results is what we see below. Now let's investigate this. So first, we see that there is we asked for entity type risk score, but the result that we were returned are different types of risks. So a cybercrime risk, a war risk, and a civil unrest risk. So that's the first level of type inference, because what this type here is, this is a parent type to the children, the subtypes, in this case, these three here. So instead of having to ask for every single type of subtype or every type of risk, we now just ask for the parent type. In this case, give me a risk score. But perhaps more interesting for this example here is that these four relations are actually what we call inferred relations. So they're not actually persisted in the database. And we know that because if I press on this relation here, it says on the right, inferred relation. And that also means that we can get an explanation why that relation was created. Because one of the great things about doing automated reasoning is that it's fully deterministic. So we can always get a full explanation why a certain inference was made, unlike in a machine learning system, at least most of them. So the result here says that the reason why this inference was created is because Wallian Securities owns an asset, this Akata oil field, which is in a jurisdiction that is connected to the civil unrest. Now, that's the first layer of explanation, but let's look at this one right here. So if I press explain on this relation right here, we see that there's an attack campaign, some sort of cyber attack that's occurring on RBS. And so the reason why this inference gets created is because, well, clearly if it's under attack, it's under some cyber risk. But this is where it gets interesting because, well, you know, RBS will own different subsidiaries, because this is another inference, because the actual entity under attack is this subsidiary, this company named Real Estate Corporate Postikintistot, which actually isn't a direct subsidiary. It's actually a subsidiary of another subsidiary, this bank named Nordisk Renting. And if we look here, why is RBS and Wallian exposed to the same war score? Now, if we press explain here, we see this one gets interesting, so please bear with us. Because, well, the first layer tells us that Boolean has some exposure to this bond. Now that bond then is issued by this jurisdiction, which is in a war, connected to a war score. But this inference, this relation here is another inference, because the exposure between Boolean and the bond is interesting. Is a bit less, is not as straightforward as we may think, because actually there's a joint venture between RBS and Boolean who own this Huawei securities. And as you can see here, this is an example of a ternary relation. So that would be an example of a hyper relation, whereas all the other ones we've seen are binary relations. And we see that Huawei has some exposure to that bond, but if we look further deeper here to this relation right here, we see that actually the exposure of that bond to Huawei securities isn't completely direct either, because we see that there's a board of directors that sits on this Huawei securities. One of the directors is this guy named Sheng Chao. Now, Sheng Chao is married to Anna McDonald. And Anna McDonald seems to own that bond, but she doesn't own it personally. She owns it through a special purpose vehicle. Now, that's the end of the story, which may seem far-fetched, but actually it's a very common example, especially in finance or in risk, in places where we have to query for risk and try to understand risk exposure. Because the actual query that we asked, the answer to that question is this here. This is the answer to the query. What are risky banks? And the answer is Boolean and RBS. But if we zoom out, there's a whole bunch of relations that actually underlie the inference or underlie the answer to that question. So when going back to the first slide that I showed, when we talk about abstraction, this is exactly what we mean. We talk about abstracting away complexity by way of using, in this case, an automated reasoner. I find it's useful to just take a breather, and as Daniel says, a fist of five. How's any questions, basically?
Yeah, this group might not know what fist of five is.
I know.
And then
It's an inside joke.
Yeah. There no questions, although maybe Mason is always saying he's got 5 fingers up. I see. Yes, clever. So no questions yet. There was a question about comparing to Cypher.
Which one? Hassan has a question.
And Hassan does have a question. He asks, well, how is that compatible with SQL, as there is less Grakn, but a lot of SQL?
It's not compatible with SQL. So it's not. It's instead of SQL.
And then Dom asks if this is from a public data set, or is it
somewhere else? Okay.
Yeah.
So this is not a public data set. This is a project that was done a few years ago on a private data. Data was masked. That's why we can show this, but this is not public data. So unfortunately, we can't. There's no way of obtaining it.
Yeah.
Yeah.
Hassan, I want to just pass along Dom's response to your question, which was take your SQL, put it on a fire, cover it in petrol, and then set fire. Well, I don't necessarily condone that response, but you know, that is an option that's out there.
That's really funny. I do want to say I don't like to appear SQL bashing. We have great, you know, we have great respect to relational theory and the relational model. It's fun to get to SQL bashing, but I also just want to state, you know, our respect for what came before. And at the evolution of technology is just that, you know, technology comes and replaces the old guard. So we build on the shoulders of what was before. But certainly SQL bashing can be fun.
And then just as a question that
Tom is here for SQL bashing. Well, we can certainly do it.
Oh, no, we don't go that far. Hassan asks, so if he's currently using an SQL database and using SQL, what might be a way of sort of exploring Grakn?
I guess the one way of thinking of it is what's the conceptual model of what you're modeling of the data in the relational database, and then thinking, is a tabular structure sufficient enough to represent the data and then query for the questions that you want to ask. And specifically, the reason why you would migrate into Grakn, because you get a more expressive data model, so you're able to express more complex structures in a much simpler way. And you get an automated reasoner as well. So in particular, if your question is, if your queries are becoming very complex, there's a lot of logic that you're trying to represent, or there's a lot of logic that may exist in your application layer that you want to push that into an actual reasoner, and you need a reasoner. Those may some of the reasons why you may need to move to Grakn. When you do move to Grakn, it is like moving from Mongo or from Postgres to Mongo. You are moving to a whole different database. And so there are migrations that will have to be done.
Yeah. There are a couple questions that have come in since we were answering that one. Do you want to address them, or do you want to push it to the end? And Alex, you can let us know if there's a SOP we should be following.
I literally leave it up to speakers usually as to whether or not they want me to interrupt. So it's up to you.
I would say let's proceed to the slides. I get a feeling we're getting into a discussion, and I think let's hold off until the end, and then we can go full steam on that.
Cool.
Because also I think some of the slides will answer some of the questions that I think I saw in the chat.
Yeah, but feel free to keep dropping them in either on Discord or chat, and we'll get through them.
And so usually one of the questions following from this, one of the questions that follows is, how do we get to building the example that we just shared? And that's what we're going to go through, not specifically the example the demo that we just shared, but something more basic. And in Grakn, we build a schema. So the schema represents the data model, as in a relational database would do the same. And what we're modeling right here, what you see on the right, is the modeling language in Grakn. And what we're creating here is effectively two entities, a company. We're creating also a relation of type employment, and we have an attribute called name. Now, when we see here, we see a couple of things. Usually a question becomes, how do we connect an employment to the two entities, the person and the company? Now, as you saw in the previous slide, Grakn uses the concept of roles to contextualize how something plays a role in a relation. So here we say that the person or a person plays the role of employee in the context of an employment relation, and a company plays the role of employer in the context of an employment relation. And then we have an attribute that is connected to a person. That's why we say the person has a name. And finally, we say that the name is of data type string. Now, I will apologize for not having updated this syntax to the latest one. We now do not say data type, we say value. And the graphical structure of how that would look like would be as follows on the left. So we have a company, an entity, which we denote as a rectangle. There's an employment, which is this relation right here. And the person plays the role of employee, and the company plays the role of employer in the context of an employment relation. Now, let's say we want to extend the model. And we say there's now two subtypes. Let's say there's now a customer entity, and there's a startup entity. Now, we want to say that a customer is a subtype of a person. And to do that, what we do is, just as we define a person as a subtype of an entity, we say a customer is now a subtype of a person, just as we do startup sub-company. Now, when we do that, the subtype then inherits all the properties that its parent has. So by saying customer sub-person, what is happening is that a customer now also has a name and also plays the role of employee in an employment relation. And the same is true for startup, but we can also add additional attributes that may not be attached to their parent. In this case, a startup has funding. Let's say we extend the model now. Let's say there's now also a marriage that can exist between persons. Let's say we insert some data. So how do we insert data now? To insert data, and as you saw before in the previous one, if we wanted to define a schema, we start with the keyword define. If we want to insert data, we start with the keyword insert. And what we're inserting right here is effectively an employment relation between a company, IBM, and a person, Alice. And we connect them in an employment relation by simply putting them here in a tuple. And then we just simply say that that tuple in line 5 is of relation type employment. And then we also want to create a relation between a startup and a customer. The reason I'm coughing, it's getting cold here. We have the window open. That's why that's why I'm getting a bit cold here. So I'll keep speaking so I keep generating energy. So in line 7 and 8, we're trying to create we are creating a relation between a startup and a customer in an employment relation. And we do, and just as we do above, we connect them in a tuple as we are doing on line 9. And then on line 11, we create a relation, a marriage relation between the wife, which is $B, so person Alice plays the role of wife, and $D, which is a customer that plays the role of husband. Those both are in a marriage relation. Now, I want to point out, we never actually explicitly allowed a person to be married with a customer. But because a customer inherits all the roles that its parent has, they now can actually play that particular role. And that's why they can be married to each other. Now, that commit would succeed. But let's say we're trying to marry a company with a person. Will that commit succeed? Now, given the model that I just showed, that commit would fail. So something very important, especially if you're coming from a NoSQL background, Grakn imposes schema constraints at the database level. So you can't just connect anything to anything. So my brother can't marry himself if someone by mistake created that relation or whatever. So let's look at some other relations that we could create in Grakn and how we do that. So here we've got an example of a reflexive relation where Alice is teaching herself. So Alice plays both the teacher role and the taught role in a teaches relation. We have a symmetric relation. Here we have two different people, $X, $Y, Alice and Bob, who play the role of spouse in a marriage relation. There's an example of a hyper relation. So, and perhaps if anyone knows graph theory, you'll be familiar with what a hyper relation is, but perhaps those who may not be familiar, if you consider a binary graph or a binary relation or effectively a property graph as being a pair of vertices or a pair of nodes, the difference here with a hyperrelation is that instead of being a pair, it becomes a set. So we can have an n-ary relation right here. In this case, this is a ternary relation with multiple role players in one relation. And here we have a movie, a person, and a company playing different roles all in one relation, the relation being of type purchase. And we can add also more role players in one relation. In this case, we have 5 role players in a joint venture relation. That's the example that we saw in the demo where we structure the joint venture as a relation where we denote all the different owners that exist in that relation. And because relations are also first-class citizens in the model, we can actually create relations between relations. So what we're doing here on line 4 is not just marrying Alice to Bob, but we're also adding a variable name, attaching that to a variable to marriage, $M. And by doing so, we can now actually use $M in another relation. So we have $L, which is a city, and we want to connect the marriage and localize it in London. So now the event that's a marriage, that's a relation because it's an event. It should be a relation. That's how we want to model it. But we also want to localize it, and we want to localize it by using a relation of type locates. And we can do that in Grakn by nested relation, again by adding, as we do on line 7, saying that the marriage plays the role of located and the city plays the role of locating. So now we created a nested relation between the marriage and London. And Grakn also has an inbuilt automated reasoner, and that allows us to create transitive relations. And here we have, if London is in the UK, and if the UK is in Europe, which it still is, may not be part of the EU anymore, but it's still in Europe, we can now infer that London is also in Europe. Which I appreciate some Brexiteers may still want to exit out. But to the, I don't know, Hassan, that's, even Grakn can't solve that. That would be a Graql exit. But to model that logic here, we would create a rule, and the rule, if you think of, perhaps for those familiar with logic, a rule is effectively a horn clause. In other words, given a set of conditions, we infer a new atomic Grakn statement. And so what we're doing here is we're saying that when $x is connected to $y, and when $y is connected to $z, then $x should be connected to z. And so that will transitively reason over all your data, however big it is. There's no limit. And we can also create more complex relations in this case, or different types of inferences. In this case, an equivalent relation. If we know that a child has the same parent, well, we can then infer that they must be siblings, which is what we're doing here by saying the $p has different children in the form of $C1 and $C2. Then $C1 and $C2 should be in a siblingship relation. And let's say we're looking back at the query that we saw before, this complex reasoning query, where we actually want to retrieve both explicitly stored data as well as implicitly information. So the result of doing this query would be the following. Now on line 2, we're querying for organization. That infers every subtype of organization. Then we query for every premise, which infers every subtype of premise. And then by saying, give me $OR connected to $PR, that infers every combination of organization and premise. And then finally, we ask for $PR connected to $UK, which would infer every location in the UK, given the transitive rule that we would have created. Now, this query, if you were to do it in SQL, would be more complex. And I hope you appreciate that would be an understatement because we could also lead to queries that look like this. And we've seen users in Grakn to abstract away these types of complex queries in just a few lines of code. And again, it's not about SQL bashing at all. It's really about understanding different types of technologies. In this case, using a higher level language to automate the important operations that are performed without having to think about them. And there's actually a blog post that looks into why and how actually this query looks in detail, because of course it doesn't tell the whole story, because there's also schema that we have defined in Grakn. But I hope it helps perhaps Hassan understand better. So in summary, what is Grakn? So now, there's a couple of things that we would highlight. The first one is that of the knowledge schema. Now, the knowledge schema we define as being in Grakn a direct implementation of an entity relationship model, specifically the enhanced entity relationship model. It uses a hypergraph theory under the hood to enable us to model both hyper relations and hyper entities. That is also, the schema, by the way, is flexible and extensible at any point in time in a database. So if you do have a terabyte in there and you want to change the schema, you can. And the second part is the automated reasoning bit. So at query runtime, Grakn performs deductive reasoning through OLTP type query. There's not OLAP, there's OLTP. And it does it through backward chaining, for perhaps those familiar with what that means, specifically through rule-based reasoning. That's the type of reasoning it does. And now everything that Grakn does with regards to the schema, the reasoning, anything, is really ultimately to create a higher level language. And because a lot of the science that we do and the math that we implement isn't necessarily new. A lot of it has existed for a long time. Grakn is heavily inspired by Prolog, the data log to be more specific. The problem is that a lot of these technologies have been too complex to adopt, and so for us, where we're putting a lot of our effort into making a language that is simple, that is elegant, that is beautiful to use, that gives you the ability to use these types of intelligence to build software, and build software in a way that doesn't require you to have a PhD from Oxford or a PhD from Cambridge. So just as we're wrapping, because I know we're running out of time. We had a conference about a year ago, just before BC, before COVID, and that was great. We had 300 people attend. We had some great speakers. These are some of the logos that attended and spoke. And I guess as a final parting word, now our space where we fit in the science and the AI that we do is that of knowledge representation and automated reasoning. And to be very precise, it's not machine learning. So if you're thinking of architecture, if you are an architect thinking where does Grakn fit and how does that relate to other components in your software stack, Grakn sits in the middle as the knowledge base, the knowledge graph that stores information and that works together with whether you've got your machine learning pipeline, your NLP stuff, your knowledge acquisition, NLU pipelines. Grakn sits in the middle representing your data and then reasoning over it to get the right answers. So I hope I did well, Daniel. Thank you. And I turn to you for any comments or questions.
Yeah, absolutely. Alex, you'll have to let me know if there's any questions from the YouTube, but I'm just going to go back up to the top here and roll through them in the chat.
Will indeed. So get those questions in chat.
You can, or you could. I'll read through the ones in chat and get those answered. Then you can read through the ones in YouTube. But up to you. I'll start from the top of the chat and work my way down. Do
it. I've got none on YouTube at the moment, but that might change.
So we talked about how you might approach migrating from a relational database using SQL to Grakn. Tomas mentioned that. So Stephanie, intuitively, maybe a broad question, but is the way this works related to / similar to Prolog?
Yes, yeah, absolutely. So specifically data log. The difference being that Grakl is a query language, is a database query language.
But Greg, thank you for the question. Greg asks, how do we get these deeper relations from the query? E.g., the example given in response are abstracted, complexity is abstracted away. How might we verify these rules or the query path that's executed? And just as a clarifier, Greg meant that the automated inference that is enabled decided the result to be included in a return from a query was correct.
Well, so the way the rule works is that ultimately, given X, Y, and Z, then therefore, 1, 2, and 3. So the reasoning itself is the inference is deterministic. So you can, if you have some data, you could write tests that check that, if this query, this should be returned. So you can run those tests. That just really depends on what you're building. So yeah, of course you can run those tests. We have those tests internally to make sure that Grakn actually works as well.
And then Hassan asks, can you assign rules or rather turn them on or off using the console?
You can define and undefine a rule. So rules aren't actually dependent on other concepts. So a rule does exist on its own. So if you do want to undefine a rule, you can quite easily do that. We consider rules to be part of the schema. So just as you can extend the schema at any point in time, you can also change the rules at any point in time. So if you have some sort of toggle in your GUI, you could say, okay, turn out the rules and then undefine all the rules, define and then define them again. That's quite straightforward to do.
I'm just moving over to Discord just to go back to some of the questions that Dom had asked earlier. Do you suffer from the same write performance issues compared to RDBMS that Neo4j does?
I guess we would have to know what specific write issues you're referring to. Where right now, we actually today released the alpha version of Grakn 2.0. And that's been almost, to be honest, been a rewrite of the backend architecture. I guess to give you a little bit of background, did there is that so up until 1.8, Grakn run on top of the software we used that persisted the data was Cassandra. So we leveraged a key value pair store to build and on top of that we had Janus graph that creates a binary graph. On top of that we create a hypergraph. On top of that, we create an all knowledge representation system and then the reasoner and then Graql. So what we did instead, we removed Janus graph, removed Cassandra, build our own hypergraph storage engine. Effectively, we built a whole new graph database. And then we use RocksDB, which is a much lower level database than Cassandra. But RocksDB is effectively an embedded database where you store just byte strings byte areas as key value pairs. And that is incredibly performant. And so we're looking at 20 to 40x performance improvements with Grakn for both read and writes across the board. We'll be publishing those benchmarks soon. We have a system that runs those against Neo4j, so you'll be able to see that for yourself. I don't want to say anything just yet. I mean, it's public though in the forums, but I don't want to make any commitment. But we're seeing better performance than Neo4j on almost every single test.
And then Don also asked, can you handle hundreds of millions of objects given enough memory?
Yes, we'll be releasing those tests as well.
Cool. And then last couple from Dom, is there ever a point where a relation has n number of role players and that impacts performance?
Yes, that is possible. So of course, hard to predict exactly when that is. We have a way to avoid the supernode problem. I forget exactly what that is. I can't really comment on that right now. But yes, there are instances where that can impact performance. I'm not quite sure how that now is with 2.0, but I'd say give it a try. And I would encourage. We did release 2.0 as alpha to just get the community to just really destroy it and find everything that's wrong with it and then report the bugs to us so we can really iterate on it very quickly. So if you do want to break it, you'd make us very happy.
You heard it here first. That was an open invite to break it. Right?
Very open invitation.
Simon asks, what use cases are your customers using? So everything from, we obviously talked about financial services use case. Through that, we've also seen use cases in fraud detection, in cybersecurity, to robotics and intelligent robotics systems, everything all the way over to life sciences, where we talk about precision medicine, drug discovery, drug repurposing. We just did, Brother Tomas led a project on biographic COVID, which is a research graph for biographic. My mind is just now on blank in the depths of biographic. The conference, as we mentioned earlier on, you can probably set it on YouTube, but the conference that we ran earlier this past 2020 February, we had community members present on space mission design using Grakn, on a tax assistant app, on DevOps and master data management, customer 360. There's been some insurance use cases. There's obviously a lot of like supply chain, manufacturing use cases that are extremely relevant. So it really spans the spectrum. We've got a ton of community members that are just like, they're just playing around with everything and anything that they can touch with Grakn. So it's sort of a wide question that I hopefully I answered some semblance. Appreciate that. Stephanie asks, in what language is the automated reasoning component implemented?
Java.
And Scott asks, is performance solely with CPUs, or are GPUs being considered for processing the graph data entities?
CPUs.
Thank you for that question, Scott.
I'm sorry for the short answers.
No, this is we're rolling, rocking right through them. Greg asks, are there any libraries to integrate with backend frameworks like Spring, or plans for those similar to GraphQL, Java, Kotlin? And thank you for we appreciate it. It looks awesome.
There's a bunch of so we offer 3 client drivers that are maintained by us, specific Node.js, Python, Java. And then in the community, and I think Daniel may know more than I do, there's a whole bunch of other community drivers being built in Rust, C#, I think one in Ruby as well. Julia also very actively developing in the Julia community. And I think there's another one that I'm forgetting. There's 4 or 5.
Go, Julia,
and Go as
C#.
well. Go.
Yeah.
And for any GraphQL implementation, for that, you just use the Node.js driver. You know, making a generic with GraphQL and Grakn is difficult because the way GraphQL configures the data format doesn't directly map to the Grakn entity relationship model. So it'll be dependent on your application and how you effectively configure that. We've thought of it, but the Node.js driver should be enough to do that. There are a few open source projects that use GraphQL as an implementation, and those you can look at those for reference. Yeah, I hope that shed some light.
But good questions, thank you. Dom wants to know what is with graph-based databases and Java.
Well, Java has the right balance between being able to be low level enough to touch some operating system level functions, while being also high level enough that it's not too verbose. So that level is just the right one, and so you would never be able to do it in Python because that's just too high level. And then we may so the benchmark results have been really, really good, actually better than we expected, because initially the plan was to actually rewrite Grakn in Rust. So we had real plans to literally rewrite Grakn entirely in Rust, but later this year. But the performance has been much better than we expected. So although we still want to do it in Rust because the performance will be off the charts, that now has been postponed to later because the performance so far has been satisfactory.
Thank you so much for being active listeners and asking such great questions, engaging with us. It's honestly, it's so much fun for us to talk about this kind of not only Grakn, but this topics in general. So I really appreciate everybody's enthusiasm and interest.
Yeah, thanks so much for sharing with us as well. It's been been an eye opener. Plenty of thank yous coming in from YouTube as well. So
Good.
Last shout out to the YouTubers before we go private. Any further questions? Otherwise, the usual: likes, subscribes, all that jazz. You've got to push the buttons. Yeah, exactly.
Yes.
Awesome.
Subscribe to our channel as well.
Indeed. Your link is floating around in the YouTube chat as well. So.
Yep, it's youtube.com/c/Grakn Labs.
Awesome. Right, well, thanks, YouTube. I shall leave you. I lose the stream as I'm on YouTube, says Dom. And it's unfortunate. You could jump on the Zoom. All right. See you later, YouTube. Bye-bye.
Thank you all. Bye.
Bye.
Cheers.
Let me see.